Great.
Thank you for the introduction. I know that this is the last talk before lunch, so I try to keep it short. Today, I will introduce HEaaN.STAT on encrypted statistics using HEaaN. And I was very impressed by some previous talks because it's one of the most challenging in the homomorphic encryption area is many people say that how fast it is, how large data can handle. So, previous talk actually showed a great examples. How can you handle all big data using homomorphic encryption and multi-party computation? And now we will show that how we can generally apply the homomorphic encryption for the statistics. In the morning section, actually, Catalina mentioned that public do not know about in the dark about the usefulness of the privacy and technology. But I think that also even for the experts in the homomorphic encryption now doesn't realize how fast it can be computed over the encrypted data. So in this slide, I will show, and also this in my talk, actually, my colleague will give some live demos. So how can we handle it? How fast can be done? Yeah. The slide is as follows, and actually, but I have to mention that this is not an academic slide. I just one thing I want to emphasize how fast we can do the analysis of the encrypted data. Yeah, so CryptoLab is a startup in Korea, and we have several products, and we have many people, and we secured funding in very short time. I will skip here, and yeah. In our last workshop in Geneva, we announced that we released the HEaaN library. It can be the fastest library for the homomorphic encryption. And there are many key features when I want today's goal of the presentation is to show the speed. So I just show the result. So this is the speed of our bootstrapping. So I think that there are many students and come from the academic research. So if you wanna try this one, then maybe you can have a much better result. For example, when you're writing some paper for the inference, if it takes about, for example, 10 seconds, if you use hours, then you can reduce the number below 1 second. But it means that you can have a higher chance for your papers can be accepted in top-tier conference. So yeah, it is freely available in the HEaaN.IT. It is listed here. HEaaN.IT. You can download it and you can use that. If you have any problems or some issues using that, then just let us know that we can definitely help you to write, to help your research. Yeah. So now I will introduce HEaaN.STAT data analysis with HEaaN. It's a basic statistical. It provides a basic statistics functionality for one variable statistics, two variables hypothesis testing, and also it supports the. When we develop this software, we think about the usability issues. So now we support Python and R data. Let me show why we started to develop this one. This is related to the requirement from the Korean government. In Korea, the Statistics Korea now wanna share the government data to the public to promote the data-oriented business in Korea. But maybe as you thought, since the statistics data can contain some private information, there can be some privacy risk to publish any data in public. So the Korean government's plan is to apply the homomorphic encryption first along with the differential privacy and data. And I hope that the initial service can be started next year. And in the service, it looks like that. For each department, before sending their data to the Statistics Korea, they apply the homomorphic encryption. So so they don't need to worry about the exposure of the data. And for the data analysis, it can be a department from NGO or even for the private companies. Do you want to use that for the statistics, or do you want to do the data collaboration with their own data? They can just use the data because the data is encrypted, so there is no worry about the privacy concern, so they can use it. Yeah. Now, let me show the result of our software. Yeah. So we tested our software using our large data set from 1 million to 10 million. And it shows our performance. For here, the whole, the 10 million data set, it takes from 1.5 seconds to 5 seconds. Maybe there is some difference between this block and this one, and it is because some nonlinear functions is used because we have to use a lot of bootstrapping for the accuracy. So there is some gaps between this one and this one. But one thing I want to emphasize is that actually it's a constant plan because for the statistics. Actually, for example, the square root or something, it needs to be done just once. So maybe we can get a linear scalability for systems. And also, of course, it's highly scalable. So if you want, actually, it was done by using our GPU implementation. So if you want to add some more speed, and if you put more GPUs, then you can get a better speed for that. Now, let me show you the accuracy. Actually, it is using the data from the statistical here. So it's not a real data. It's a synthetic data. And the data size, data set is 9.1 million. And it has 3 categories. And for the maximum value, it's 16 million. So the range of the data is quite big. And this one shows the result. And as you see, there's a very small difference between the plain text result and ciphertext result. But now, you can handle such a large scale numbers using the homomorphic encryption. So I think that we are almost ready to commercialize homomorphic encryption in the real world. So that's one of the reasons why I expect that we can start the service next year. Now I want to show the APIs of our software. Yeah. In this, many people who are doing the statistics using pandas. So I just show that the pandas API, HEaaN.STAT API is quite simple. There is a very small difference. For example, DF and HF, almost that's all. And when you complete the result, since here it is encrypted, you have to do the decryption. You have to call a decryption function to get the result. So, as you know, it's easy to use. We also support R. For the statistics community, R is one of the most popular languages. So, implement that actually similar to Python for the R. The shape is almost the same. So, actually, we try to introduce this to several companies, and the engineer in the company said that it's very useful. Actually, it's very easy to use. Yeah, so I will introduce some our demos. Actually, my colleague Youngi will give some live demos for our software dataset, like that. And for the demonstration, actually we show several things about what could come into the issue. We show you pick something and Youngi will present.
Hello, my name is Youngi, and I'll demonstrate the HEaaN.STAT. Left is plain text script and right is hypertext script. I first import packages and load data. Data is so large, so it takes some seconds. Data is looks like this. 9 million rows and 26 columns. That test case, I prepared the encrypted data. I encrypt this, plain text encrypt and load the data. So I'll show you the calculation of operation. First, I load the business sales column. And this is for GPU acceleration. So now we can calculate mean in plain text. Then the result is 702.74, and in the type text, the result is encrypted, so you have to decrypt to see the data, the result. Then the result in that case is also 702.474. Variance and standard deviation are similar. This is 9 million data. Standard deviation. HEaaN.STAT support the confidence interval and t-test. This is the Python SciPy API for 99% confidence interval for mean for all the business sales column. The result is from 654 to 751, and the test case, the result is from 654 to 751, almost the same. And t-test for mean, the hypothesis is that the population mean is 7. So t-statistic is 0.1466, and in the test case, we calculate that and equate to the result, and 0.1465. We also, HEaaN.STAT also calculated the covariance and correlation. We call one more column corporation sales. And covariance and correlation. The covariance of that test is 2806, 2806. Okay.
Thank you for the demonstration. And so, yeah, now we have shown that how it works for the encryption. So it's tested over. There is a title. It's 26. for a 9.1 million cell. Actually, when you do the analysis after applying the homomorphic encryption, okay, you can get not a hard real time. Someone asked me that, what about the comparison with the plain text return? So, for example, how long does it take for the plain text? Of course, it's much shorter, but as you see, for the message data, it just takes about 1.5 seconds, 2.5 seconds. So it can be usable. We are ready to use. If you want to have more speed, then just use more GPU card. Then you can get a much better result. Another difference, yeah. So now I want to mention that I'm very happy to say here that we will release the beta version of HEaaN.STAT. You can download the CPU version of the Corr. It is free for research and non-commercial use, so anyone can use that. Not for commercial use. And for the GPU version, actually, the GPU version shows a much better speed. If you email us, then we can provide you our GPU version so that you can use that. And actually, our demo also shows that for the research purpose, why you need to use our HEaaN library, because many of the high speed comes from our use of the HEaaN library. So for the researchers, if we use ours, then we can get much better results, especially for our group. Now, let me show the work. Last September, we released HEaaN library. Okay. We released HEaaN.STAT, and maybe 6 months later, we will release another software related to machine learning. And also, and maybe some more functions and the HEaaN.STAT will be added at the time. And also, we will give a tutorial at the Crypto 2023 video. So, if you join the tutorial, then maybe we will show some hands-on sessions, each of 1 day tutorial. We will do your hands-on sessions, so you then will know how can you do everything by yourself. Thank you.
Thank you so much. We have time for one quick question before we go for lunch. Any questions? So maybe I ask a question. You said maybe in 6 months?
Yes.
So it's just a maybe, it's not, we don't know.
We'll try.
Okay, that's great. Okay, thank you so much. Let's thank the speaker again. Let's thank